Hello, I thought I'd start by going over a bit about the CS1 Game Engine, its vision, its current state, and some direction that development is currently taking, and some ideas even beyond that. So, as you can see in this slide, I am emphasizing that this is a learning platform, but it can result in applications that are production ready, with the exception of the data store. The data store that's used in the system, I'll let you know right off the bat, is just a simple flat object data file-based data store. But the same basic API can be used to work with a more resilient, more productive data store. That said, we're also looking to build creativity and leverage creativity, and to pursue some advances in VR experiences and applications. Okay, let's just go a little further. My name is Eric Eisman, and I am enthusiastic about education, and I live in Maine and teach in Maine. Okay. So CS1 is something that I came up with in response to some students that had inquired over a year ago now. Some students that inquired about building 3D applications that were integrated with IoT devices. That's how it started, and they wanted certain abstractions built in so that they could easily get a basic application up and running. So that's where it started. I have since done some research into uses of different learning methodologies and design patterns and so forth, and tried to integrate them in as much as possible. And you'll see, I'll show you a slide later on that has some of the research that's kind of driving the development of this project. Okay, so I did conduct some surveys last year in my implementation at my school, and pre and post test, I saw a growth in students' basically self-efficacy in terms of computer programming. And this came into consideration in implementing this in other schools, throughout the world, implementing this system, because I am starting to see some positive results from it. The system has a lot farther to go before it's a really sound curricular alternative at this point. Okay, we do support project and experience-based learning. Project-based meaning that students will be expected to have some type of work product at the end of a unit or even lesson. That could be little mini projects. Experience-based learning is something that maybe a developer would design maybe a VR experience or a 3D multiplayer experience, and then put the students into that experience as the learning process. So those are just two different angles of using the system. And you can see kind of how I fleshed out the different aspects of the system into the game engine, the integrated development environment, and curricular templates. And I have examples up on YouTube if you want to look at some of the early examples of using the engine. We'll move on here. So the engine develops VR applications that run on VR headsets, and also applications that can be installed on phones as progressive web applications. As you can see right here, here is an icon where the application has been installed on a phone, and students can immediately have their application running on a phone, a tablet, desktop, and VR devices. I'm even running it on my TV now as well. Um, Over here, we can see some use case examples in different courses: math, engineering, computer science, physical education, even foreign language and language arts. Here's some use case examples that you might want to look into. Here's some of the research I had mentioned earlier, looking at students' motivation being enhanced by project-based learning, and looking at project-based learning within mathematical context, and so for designing digital games, and assessing over here this example here of data story assignments. So there's a lot of research out there that's kind of driving what I'm doing, and I try to balance my time between research, reading research, reflecting, is this the right research to guide the architecture and design of the system? Reading up a lot, considering what needs to guide the architecture and design, designing some of the system, and then implementing it, the actual programming of it. Okay, so I do have some videos out there, again on YouTube, that are kind of outdated, and you can look through those. I also have a Discord channel as well, and you can reach out to me and I can give you an invite for the Discord channel. And I have GitHub repositories for the related projects in this. Okay, there's a little illustration there of the current implementation for the Python interface. So now, if you look over here, the CS1 game client, the CS1 game client is, in fact, just the regular CS1 game engine. And what I have done that's a little bit different than this picture is I've pretty much baked the Python client into it, and I am using Brython. I'm using Brython, which is a Python 3 implementation, where it gets compiled into JavaScript at the start of the application running. So that's what I'm using currently, actually within the CS1 Game Engine. So this is not separate. You would just do a couple setup steps with the CS1 Game Engine to make to basically avail the Python code interface. And then another aspect of integrating Python into the CS1 Game Engine is using a Flask server. So by using a Flask server, for example, over here I have a Python Flask server, and that Flask server is just basically running a microservice, basically just in this case, like REST endpoints that the game client can interact with. So we can have the game client interacting with the Python server. And notice right here that this connection is primarily for wake up and keep alive, and that what we would think is a better design for a multiplayer game would be to have the game server doing the interaction with the Python server, because a lot of times in multiplayer we'll have many clients that would very likely need maybe the same information, since we're sharing updates across the multiplayer network. So it'd be best in most cases to, with this connection between the CS1 game server, which is a Node.js server, it could have connections, run requests over to the Python Flask server. So basically that would require editing some code over here on the CS1 game server and editing some code on the Python Flask server. Okay, for the Python client that would be in the CS1 game engine, again, I folded this into this. For the Python, again, that gets converted by Brython right? And it gets converted by Python into JavaScript. For that, um, that would be some place that people can program Python. So users can program Python that will be transpiled by Python over here in the CS1 game client. They can also program microservices in the CS1 Python server, a Flask server, and users can also program the requests, the interaction between the client and the Python server on the Node.js server. Okay, so those are the three places that we can have the Python code running. It will be running either on a Node.js server, where it will be calling down to via socket to the game client, or calling out via just standard HTTP requests, or it could be a socket via a Python server. And all of this, I would like all of the programming to be exposed to students in a very easy to manage way. And that would be using the CS1 IDE. And this is what it looks like. The IDE is basically a code editor up in the upper right, a little log area in the bottom right, and then over on the left, this is a lesson area where it has basically a Google Slides presentation. And then if you click right here, it has an associated Google Forms quiz. So students could go through the Google Slides presentation, for example, and they could go through the slide, set of slides, and complete basically the process that's outlined. They can complete the process that's outlined over here in the slide presentation in the code editor, because the code editor will automatically bring up the file that they need to interact with. Okay, so in logging in to this particular IDE, here's the idea. Here's the basic idea. So I'll just refresh this, which is okay. So right over here, the idea is when you log into the IDE, you pass in the name of the project. Now these are hosted on Glitch. I use the glitch.com free service because it's very obviously free, and it's reliable. It'll shut down every now and then, so you do have to mitigate for that. But you put the name of the project and you put the admin key for the project. So any project should have some type of admin key that's stored in some type of environment variable that can be accessed. So this login, so basically when the IDE will call out to the remote project. In that remote project, if it's just a standard CS1 Game Engine project like this, that remote project would interact. And if I go over to the server, let me just go ahead. So this is what this is the actual in the CS1 Game Engine. This is the current client code that can get changed in Python. The client interface for the CS1 Game Engine, it's basically just exposed in the public route, myscript.py. And before we can connect the CS1 IDE to this CS1 Game Engine, we need to authenticate through the server. So in the server, I have an admin section, and then I have an IDE API. And here's basically what I have so far for the IDE API. Basically, I allow a login to come in, and that login gives the basically authenticates with the admin, because you have to be the admin over whatever project you're logging in. It authenticates with the admin, and then opens up a secure socket between the IDE and the project. And that particular secure socket, in actuality, fails fairly often. You have to refresh and reboot the IDE because it's running on glitch. And we're actually relying on 2 different projects being live at all times for this to work. That being said, it's free and it works well. Just be comfortable refreshing the IDE, and if you notice that something's not saving, you just need to copy that change and then refresh it and paste it in. Things like that. All right. So again, if we log in, it will associate a particular file that's in the project. It will load that into the editor, and it will load up an associated Google Slides presentation, and it will load up an associated Google Forms quiz. Now, how's that done? I can show you in the IDE project. So if I go to CS1 IDE, let me do that so you can see what that looks like. So the CS1 IDE is, again, just another glitch project, as I was inferring. So here's, let me see where I have the CS1 IDE project here. All right, I have so many projects loading up here. Okay. You can see a lot of other projects that I have over at Glitch. Now in the CS1 IDE, just get that project open here. All right, in the CS1 IDE project, if we look into the lessons section, we have templates. And these templates are basically just the entire templates section is just JSON. And then each lesson is another section of JSON. And if you look at it, it basically has a URL for the lesson, and that's just the Google Slides published URL for a published Google Slides presentation. And the quiz URL is just a URL for a published Google Forms quiz. Code template is something I was just thinking about implementing. I haven't done that yet. The save target, however, is the file path for whatever the source code is that's associated with that particular lesson. So this is right here, the save target. Again, that is the file path for the source code that gets loaded over in the code editor. So the students don't have to think about, what section of the source code to work in. It's already pulled in for them. And then they can just, once they change the source code, if they change something, you can see over here this highlights, they can click save, they can perform a remote build if necessary. But for the Python, since it's saving in the public directory, they don't even have to run any compilation step. They can just click save, and then they can launch their game. And they can see it working from there. So what I'm looking for at this point are other people working on this project that are willing to work within a Python Flask microservice project that can integrate with the CS1 Game Engine server and CS1 clients. And again, the clients primarily just for sending some periodic wake and keep alive calls. Because again, all of these will be running on glitch servers, which you have to basically wake up when needed. So I'm looking for people to contribute thoughtfully to Python Flask microservices that can interact with the multiplayer game server and with the actual multiplayer clients. And I'm also looking for people, who want to expand the even the game engine to expose more globals of the game engine to the user. Like for example, let me go over here. That's the IDE. Let me look at another example. Here. So over here, you can see I am accessing, where is this at? Um, the window CS1 object. The CS1 is the global object for the game engine. And I expose a log function that will log something into a 3D VR, um, basically a plane. It puts it on. So all of these global CS1 game engine, functions and so forth, the API for the game engine itself can be worked on as well, so it works better with Python if you want. So just to see, for example, what that CS1 global object looks like in it right now, if I were to go maybe over here, launch this particular game, maybe if I go in here.
Okay. Welcome to CS1 Community Park. Please join us at 9 p.m. for some tasty roasted marshmallow s'mores.
So all of this box was created and animated using Python, and this was logged out right here using Python. Now if I open up, for example, the console, and I go over here and go to the CS1 global object, and you can explore that. You can see I expose a lot of things here. There's a lot of things already. There's I'll probably take this other player out of there actually, but there's a like BGM object that is for controlling background musics and environmental sounds. There's gives you access to the camera directly, gives you access to the database API, which you can get and set values of the user data. Gives you information on the type of the device that's connected. There's all kind of stuff. It gives you access to other game-related things. Game is running, has begun, blah, blah. So, and gives you example, here's that log function. If I just did this right here and I said log test, for example, I'll show you log test. And I go into here, we can see that it puts it up in that. So the CS1 namespace is being used as the game engine namespace, and other functionality that's kind of Python. Well, I don't see why it has to be Python specific, but any other functionality that you'd like to build into that I'd be open to looking into that. Okay, so to run down and review, let me just close this out. All right. So to kind of review, I'm looking for people willing to write some microservices that might work well with the game engine. Again, the microservices will be talking via a Python Flask server to the CS1 game server, and possibly a little bit of communication between clients in the Python Flask server as well. The Python multiplayer game server is a Node.js server. Okay, just point of clarification right there. So I'm looking for people willing to work with some Node.js code that would interact with the Python Flask server and with the also with the client. Okay, and on the clients, again, one last review on the clients. The Python code that's written in for the client is in a public space, so called myscript.py, and this automatically gets converted by Python into Python 3 syntax whenever the game loads. Okay. Hopefully that kind of outlines everything for you. If you, also, I guess one last thing, if you'd like to make more Google Slides presentations or Google Forms quizzes, you can add your own lessons that would be available. And you can just remix the IDE and make your own set of lessons, in fact. Just like this lesson right here. Loads up a particular set of source code, a particular source code file, It loads up a particular Google Forms quiz, and it loads up a particular Google Slides presentation. Okay? Any questions, put them out there to me, and I will get you some clarification. Thank you for listening, and have a most wonderful day.